Hello, everyone. A very good evening to all of you. I welcome you all for this webinar this evening. My name is Ben Daniel. I'm the Chief Editor of Packaging Middle East and Africa magazine, and I'm thrilled today to be your moderator for today's discussion. So, we are here to explore some critical areas of a very important topic within the packaging industry. So, the theme of today's webinar is how demand for recycled PET is growing globally and the right way to integrate it into your packaging. So today's world is witnessing a surge in the desire for sustainable packaging. Leading brands and countries and already they're all paving their way towards this. The question is, how can your business thrive in the shifting landscape? So we have a very interesting presentation from Husky today to explore and to give us more details in this very important subject. So now let's meet our expert speakers. First, we have Philip Parabuts, who is the Business Development Manager at Husky Technologies. Just a very quick intro about him. He's got a solid track record of contributions in the rigid packaging sector. Philip's expertise in mechanical engineering is an invaluable source for us. We also have Pedro Oliveira, who is the business manager of PET systems at Husky Technologies, bringing over a decade of experience. Pedro's educational background in materials engineering makes him a key asset to today's discussion. Philip and Pedro will share their insights on today's topic. So let's get started and explore the path to sustainable recycled PET packaging. Over to you, Pedro and Philip.
Good afternoon, and thank you all for attending this presentation titled How Demand for Recycled PET is Growing Globally and the Right Way to Integrate it into Your Packaging. My name is Philip Parubit. I'm the Business Development Manager supporting our business in Middle East and Africa, Southern Asia, Southeast Asia, as well as ANZ. And I'm joined by my colleague, Pedro Oliveira, who is the Business Manager for PET Systems. Let us begin. So briefly about our company, Husky is a top industrial company providing solutions for the delivery of foods and beverages, medicines, and other essential goods. Husky has been in the business for nearly 70 years, and we are among the pioneers of PET packaging starting since the late 1970s, and today it represents around 70% of our business. And in that time, recycled PET technology has become an ever-growing part of our business. So for this presentation, I believe it is helpful to start with some definitions and some facts. In other words, to get the big picture. And we start with PET bales, which can be collected formally or informally in bags. This material is brought to a recycling center and is inputted into the sorting and washing step. So this is a type of equipment that is usually sold together, could be sold separately. And the input to this equipment will be those bales, whether they're already packed as bales or whether they come in as bags. And the output of the sorting and washing step is going to be the clear and light blue washed flake. There are often many different steps involved in the sorting and washing steps to remove all the contaminants. And here I'm talking about, for example, the bale breakers, a trommel, magnetic eddy currents to remove anything that's magnetic, vision inspection system to remove anything that's colorful. We have a grinding step to take the PET bottles and grind them into a flake. Then there's a zigzag sorter to separate out all the lighter plastic materials. And then it goes into the washing step, which has various steps of washing, a float sink to also separate out the different types of plastics. And the result of the sorting and washing step is going to be this PET flake. It is important to know, however, this flake it's washed on the surface, but it's not decontaminated on the inside. This is still non-food grade flake and not suitable for bottle-to-bottle recycling because of those volatiles, which are still located in the middle of those flakes. However, many recyclers do operate with just sorting and washing. They are the big business for selling hot wash flakes in the market for non-food grade applications, strappings, polyesters, and fibers. They all use non-food grade recycled flake. But the question becomes, what about food grade? What do you need to have to be able to achieve food grade flake? And here we need to include a decontamination step. And here is usually a separate piece of equipment. You have some OEMs which include all the sorting and washing and decontamination under one umbrella, but oftentimes it is a separate piece of equipment offered by another OEM. And the input of the decontamination step is going to be this hot washed flake coming from the sorting and washing step. And the output of the decontamination step is going to be this food grade flake, or it could be food grade pellet. Today, more often than not, it's going to be food grade in pellet shape as opposed to flake. And the goal of the decontamination step is to remove those volatiles. And there's often many different technologies which are deployed to achieve just that. But usually in all these technologies, it's usually a combination of heat and time to be able to precipitate out those volatiles in the middle of the flake to make it come to the surface and then evacuate it out. And usually this includes extruding the flake into a melt. There's usually a filtration step as well. And at the end, there's usually a pelletizing step as well. Different types of technology might change that order. Maybe the filtration and pelletizing happens, or rather the extruding and pelletizing happens before the decontamination or can happen afterwards. The order can change. But usually there's some combination of heat and the time in order to get those volatiles out. From the decontamination step, when it comes in pellet form, there are two shapes that can come out. It could be a spherical pellet or it could be a cylindrical pellet. By virtue of the fact that most of the pelletizing happening in the decontamination step is occurring underwater, we're often finding that pellet to be spherical instead of the virgin resin, which is often in cylindrical shape. Both of these shapes work in injection molding processes. We are seeing both types of pellets being deployed, but it is important to note that the spherical shaped pellets is more difficult to melt them. It's more difficult to generate that shear heating. So care must be taken in the injection molding process in terms of the scope of the injection molding machine and the process to make sure that material is properly melted. And then finally, this material is injected into the preform and then finally blown into the bottle. So recycled PET does support bottle-to-bottle recycling. It does support the circular economy. Let us see how recycled PET fits into the bigger picture. So first, it is often important to note that recycled PET is often mixed with virgin PET using a blender. In many cases, brands are pushing for 100% recycled PET. They see that resonates more with consumers to have 100% recycled PET. But oftentimes, due to the cost of recycled PET or the availability of recycled PET, we're seeing 25% of rPET being mixed with 75% virgin, or maybe 50-50 or 75-25. We are also often seeing colorant being added to the mix, and the purpose of the colorant here is to mask the discoloration that often comes with recycled PET. The consequence of colorant is that it acts like a lubricant. And together with the fact that we have a lubricant in the colorant and we have the spherical pellets, which are already difficult to mix, makes the injection molding process even more challenging. So more care needs to be taken in the scope of the injection molding machine and in terms of the process used to make the preforms. The virgin PET itself is made using two building blocks, MEG, often around 30%, and PTA, often 70%. And both of these building blocks can be made using renewable or non-renewable resources. In any case, the outcome is always going to be 100% recyclable virgin PET. One example of this is plant bottle. As many of you might have heard, around 10 or 12 years ago, plant bottle was introduced and still being deployed today. When it was initially launched, around 30% of plant bottle was made using renewable resources. So here the MEG component was made using bio-based resources from corn and other types of organic feedstock. And today they're working on developing 100% bio-based bottles. So here both the PET and MEG are made using renewable resources like corn, etc. And let me add here that oftentimes good quality recycled PET will include some specifications. Husky also has specifications in terms of the type of characteristics we want to see in the recycled PET being used in the injection molding machines. Oftentimes you're going to see specifications with regard to IV, with regard to crystallinity, acetaldehyde, the size of the pellets, and etc. Looking beyond PET, there are also alternative materials that are used to make packaging. And these can include, for example, PETG, PLA, and there are other materials as well. But here we need to be very mindful here that these alternative materials can act like a contaminant in the recycling stream. So care needs to be taken to manage, to segregate these materials out and don't mix them with the PET stream. Now that we talked about what is recycled PET, we can acknowledge the fact that recycled PET is in fact an integral part of the larger sustainability story, which includes topics such as reducing greenhouse gases and reducing the raw material consumption, also reducing waste. It can be argued that rPET can serve as a foundation of sustainability, and it can enable the reduction of greenhouse gases. It can enable the reduction of waste and the reduction of raw material consumption. For example, we often see brands deploying a combination of package lightweighting and recycled PET content in their packaging to achieve their sustainability objectives. Husky here is also working on a number of innovations to support customers to achieve other sustainability goals, including tethered closures, including the deployment of tethered labelless bottles, and also we're working to develop PET closures. We'll have 100% PET package, PET bottle plus PET closure. This is something Husky is working on very closely today. Now let us talk about some of the trends, some of the major trends we are seeing with recycled PET. And most evident, especially in the last decade, is we're seeing a major, very enormous increase in the demand of recycled PET, which is caused by the increase in global demand and consumer demand for recycled PET. We're seeing a lot of brands committing to using recycled content in their packaging. And finally, we're seeing a lot of legislation being enacted to increase the use of recycled PET. So let us explore them a little bit in more detail. Here's a map, a global map showing where recycled PET is being used on a regional basis. And more or less, we're seeing that the percentage of rPET used in packaging is quite low. So in order to support PET recycling and the circular economy, we're seeing more countries adopting legislation to support these type of goals. And this legislation is usually manifesting in two ways for PET. Number one, we're seeing an increase in the collection rates or requirements for collection rates of recycled PET. And number two, after those bottles are collected, we're seeing that there's a legislation to require that there's an increasing amount of recycled content in that packaging. And it's clear that this legislation is improving recycling outcomes. So we do expect that there'll be more legislation around the world with regard to recycled content in the packaging and also in terms of recycling rates, making sure those bottles come back to the recyclers. It's also clear at the same time that while legislation is being enacted, the industry is not waiting for this legislation. They are already proactively supporting recycling and the circular economy. Here we're seeing examples of brands setting very ambitious targets from 25% recycled content, 50%, and 100% recycled content by the year 2025 and year 2030. This is great news because it's creating demand for rPET feedstock. And we're also seeing a lot of investments today being made to match this increased demand with increased supply, which is the challenge we have with recycled PET at this time. So until that time where supply can match up with demand, we can expect higher prices for recycled PET and more variability with the quality of recycled PET. And these brands are introducing recycled PET in all types of consumer packaged good applications around the world. And they're often integrating many of those other sustainability innovations that we talked about earlier. So let us explore some of these examples. And let us start our story with bottled water. This is the first soft drink category which widely deployed recycled PET. All of these examples shown here are using 100% recycled PET. On the left, we have Evian. This is a premium brand, an early adopter of recycled PET. In this particular example, we're seeing that Evian is deploying recycled PET with a labelless bottle, so there's no label in the bottle, and all the information about the beverage is embossed on the bottle body. We also have Danone. They have also introduced 100% recycled PET and a labelless bottle across a number of their brands, which are deployed in multiple countries around the world. Suntory, same story here in Japan, also labelless bottle. An interesting innovation that they did here is instead of just exclusively putting the information on the bottle via embossing, they've also put some information on a carton clip, which clips onto the neck of the bottle. And the information here could be information about the brand, information about the water, it could be a QR code linking to their website, et cetera, et cetera. And this carton clip is completely recyclable. So I thought this was an interesting innovation from Suntory to support sustainability. And then we have Vittel, which launched a family of bottles using 100% recycled PET. They have also introduced other sustainable innovations here. They have a label using minimum ink. So the ink is only isolated to that red area in the middle of the bottle. The rest of the label is transparent. Less glue is used to affix this label onto the bottle. And they have also introduced a tethered closure to replace the standard closure before. So here they're introducing many different innovations, sustainable innovations in their family of bottled water. And finally, we have an example called Ice River, located in Canada. Here they in fact developed a complete closed loop bottle-to-bottle recycling system in their operations. They take care right from curbside collection. So they go out and work with the municipalities to pick up the recycled PET bottles straight from the curbside, bring it to their own in-house recycling operations. They make the food-grade recycled PET material, they inject it, they blow it, and then they support the circular economy in this way. And we're seeing many other types of joint ventures like Ice River occurring around the world. A lot of interest by major industry players to have to go upstream and downstream in terms of supporting the circular economy here. Next, we have soft drinks. So after bottled water, this is the next major category in soft drinks to embrace recycled PET. Here we have an example of Coca-Cola in Australia, which was an early adopter of recycled PET in soft drinks. And they have made very significant commitments across all of their portfolio, across all of their categories to use recycled PET. Very high significant percentages of rPET they've committed to use, and they're going to use it across their bottled water portfolio, their carbonated soft drinks, aseptic juices, liquid dairy products, and also nitro hot fill. The example here, the bottle you see here is a very transparent bottle. If you use good quality recycled PET, it's possible to get very nice looking transparent bottles. Many brands in industry players and brands in Australia are in fact working together to support the circular economy. So we have many bottlers and many converters and other industry players are working together in a joint venture to support the circular economy in Australia. And we're seeing similar type of interest in other countries around the world where industry players are coming together to support the production, the collection of recycled PET, the production of recycled PET, and the usage of recycled PET. This is a model I expect to see expanding in the rest of the world. We're also seeing recycled PET being deployed in sensitive categories like juices, nectars, still drinks, isotonics, and teas. Here are some examples of aseptically filled or fresh juices in recycled PET. For example, we have Innocent, which is a UK-based brand, one of the earlier adopters of recycled PET. We have Naked Juice, also an early adopter of recycled PET and their aseptically filled products, deploying 100% recycled PET. And here we see Pepsi adopting recycled PET in a number of their sensitive products, including ready-to-drink tea and also their juice brand, Coca-Cola Tropicana. And stepping outside of soft drinks, we're seeing recycled PET being deployed in liquid dairy products. And we're seeing a lot of dynamism here in this category. We're seeing a lot of conversions from other types of plastics towards PET and also from cartons towards PET. Here's an example from Friesland Campina. They converted from an HDPE packaging material towards PET. And they've also deployed 100% recycled PET. The label is a full sleeve. Includes a strip, a cutout strip, which allows us to use no glue in this case. You just peel off the sleeve and you're able to peel away the label. They converted their 38mm neck enclosure to a 32mm neck enclosure to achieve some lightweighting. And finally, they've deployed a tethered closure. So here we see a full transformation from a relatively unsustainable type of packaging to a far more sustainable packaging using 100% recycled PET, lightweighting, tethered closures, a more environmentally friendly sleeve, etc. And we're even seeing recycled PET more recently being deployed in alcoholic beverages. For example, here we have Diego, which has launched recycled PET in their family of beverages. This was first deployed in glass and was converted to recycled PET to enable e-commerce. And then later afterwards, that PET was converted to recycled PET. And we see other examples of alcoholic beverages around the world deploying recycled PET. And even beyond the beverage category, we're seeing recycled PET being deployed in food categories. Here's an example of a major international brand, Hellmann's, which is deploying recycled PET, 100% recycled PET in their food products. And they're setting an example for the rest of the food industry to follow. And lastly, even outside the food and beverage category, we're seeing a lot of innovation happening in the home and personal care packaging side. We're seeing a lot of movement from other types of plastics towards PET. When it goes to PET, we're seeing transformation from opaque colors to more transparent colors, or even sometimes it goes to clear color, where they're using the product itself as they're adding the color to the product itself instead of putting it into the packaging. We're seeing 100% recycled PET being deployed in a lot of these categories. I think there's a major push in home and personal care to introduce recycled PET into their packaging and convert from less recyclable plastic towards PET, which is a far more recyclable plastics. It is enabled here by the fact that you don't need food grade or recycled PET for these type of categories. You can deploy non-food grade or recycled PET in the home and personal care segment. So it provides more flexibility in the sourcing of recycled PET. And here, let me call out one example, a company called Ecover based in the United Kingdom. They have introduced a liquid laundry detergent using 100% recycled PET. They recognize the fact that this recycled PET will add some color to their packaging. So they deliberately added ridges to the shoulder of the packaging and in fact, taking advantage of this discoloration for aesthetic purposes. The combination of this slight coloration with ridges adds a nice aesthetic effect to the bottle here. And here I conclude talking about the global trend in recycled PET and the proliferation of recycled PET bottles in all categories around the world. So now I'd like to turn it over to Pedro Oliveira, my colleague, who will provide more information about what are some of the challenges and implications of using recycled rPET into your packaging, and how Husky Solutions can support you to integrate more recycled PET successfully into your packaging the right way.
Thank you very much, Phil, for the great presentation. So as Phil was saying, I will go a little bit more into the technology that enables you to process rPET material. So For the reasons you've seen in the slide previously shown by Phil on how we get from bale to rPET. And on top of that, the fact that everybody that is, or all the producers of rPET pellets today have used technology that is limited in capacity. So we were talking about equipment that has 2-3 tons per hour capability. We see that one thing is for sure, we're going to see a lot of different rPETs in the market. And this is what you can see in this slide, that the material becomes an additional variability on top of the machine, the mold, so the conversion technology, the application, is it a more aggressive, less aggressive injection application, and the processing of that system. So let's look a little bit into the variability. So if we think about the complete travel from bottle to bottle or from bale to bottle, we can see that there is different areas that are source of variability. Starting with the bale, the sorting and processing technologies, and also the mechanical technologies. So we can see variability in all this that you can see in the screen: metal, solid contaminations, color variation, dust, pellet shapes, different pellet shapes we see with different technologies. IV, using not only from the material we start with, also with the mechanical recycling technology, we can see different IVs and IV variation within the pellets. AA, the materials are all more sensitive to thermal degradation than virgin PET, but we also see ones that are more sensitive than others. Crystallinity, difference in crystallinity, which lead to differences in processing, and then famously talking about non-intention added substances or volatiles. We see a lot of discussions going around that. So how is Husky fits into the story? So you can see in this image that we have a significant part within this bottle-to-bottle circle, and starting from the knowledge of the resin, that I will go a little bit more from with our resin or with our rPET services, or then from drying the material to the preform, including all the steps. We see that Husky is a superior capability to handle this rPET variability. Let me start a little bit by this rPET services. So it's very important to understand the different resins, and under our systematic approach to understand the rPETs that are in the market, we are performing some resin grading services, which is basically a set of analysis of different characteristics of the resin that go from IV, AA, dust, the pellet shape, all that, and then passing it through the rPET injection molding knowledge that we accumulated over the years. And this will provide you with specification calibration. Are you really getting what you expect from that resin in regards to the rPET spec sheet? What are the differences that you will have to do regarding virgin and regarding other rPETs that are intrinsic to that rPET? And then also, what specifically from that material can have an impact on your part quality. So here you see a difference, an analysis where we analyze different rPETs with regard to solid contaminants, and then also in the preform we have seen which of those have A's and the preform. So we see also a correlation between resin, preform, and we can also extend this to bottle fries and see, for example, with solid contaminants, which one will have more bursting bottles, for example. This you see is also something interesting we can provide. It's some guidance in terms of the rPET specification. We see that most of the rPETs don't have there's no normalization on the specification sheet, so we can give some guidance on what should be on the spec sheet and what is not in this case. and ultimately giving you the capability to understand what resin or what resins we are getting into the system. And afterwards, as I was saying before, Husky integrated systems and enhanced system capability for rPET provide you really with a system that can disamplify the variability that come. We started with the dryer, as I said, integrated dryer with integrated controls with the machine, and then very important also the mixing and the melt management to ensure that we don't have variability coming from two different resins that are mixed, and we guarantee stability and uniformity cavity to cavity. We are launching a new system that will have specific rPET control screens with the recipe and traceability, and also what I would like to talk about in the next slides. I'm going to talk about the importance of the self-cleaning mold when dealing with rPET, and also something that is part of our next release is the preform quality monitoring closed loop color correction. So we'll be able to monitor the color and any color deviation, and having an automatic correction in closed loop. This together with our services, this together with our soft services like factory planning, which will provide you with the services required to adapt your operations to use of more than one resin in one system, for example, and also our continuous support with the lead to what we believe should be the approach when talking about rPET. We need to start by minimizing the contamination, ensuring that we have process stability, and maximizing uptime. Quick word on the melt delivery systems. I think very well known Husky melt delivery systems. Uniformity cavity to cavity, and also very important within the design there is a proactive dust reduction addressing the dust root cause. We don't talk about removing dust after it is created, but addressing that it is not created from the beginning. Very important when talking about your trainer and rPET is to ensure that we have a system that has the capability to deal with, for example, an IV variation. An IV variation is something that is very expected when running with rPET. We know that our hot runners have the best balancing in the market, which typically allow you to target a specific weight within a much shorter tolerance. We can translate exactly the same principle when talking about an incoming IV variation, and we can expect that the system will withstand that IV variation without going neither to the short area or to the flashing area of the process. So this is something for me that is one of the most important capabilities of when dealing with us. Also very important is the self-cleaning mold. So we normally talk about the self-cleaning mold as an enhanced capability of the system to reduce the maintenance of the mold. Here we do believe that is more of a quality assurance technology, by ensuring that having different resins that have more tendency to create dust, with a self-cleaning mold, by cleaning on X amount of cycles, we will ensure that we will always have the mold clean, and it will not produce parts with defects due to unclean vents. I have a small video of the self-cleaning mold. For those of you that don't know the technology, you can program it to do every 20,000, 30,000, 50,000 cycles, or you can just click in the button. In this video, you have the click in the button. You see here that the machine is operating in normal cycle, and then at a certain point, an operator clicks on start the self-cleaning mode. As I said, this is normally programmed, and what happens here is that the neck ring face is slightly open, so there's a mold flash, induced mold flash, and the plastic passing over the vents, the neck ring vents, will stick to the dust, and then by a free shot will eliminate those dust that is there. So this will allow you to extend significantly the mold maintenance requirements in terms of cleaning the mold vents, and will ensure that you are not producing bad parts without knowing, just because a specific rPET or a specific rPET patch is creating more dust. Over for the downstream monitoring equipment, as I said, capability of having a system that monitors your quality, deviations from the reference on the standard in terms of color, of solid contaminants, for example, and this is something that can be integrated with the Husky system. All this part of the Husky Complete offering, everything I told you about hardware, and also our soft skills and our full digitalized delivery model that we have in our system. Training services as the Husky Academy, and also our OEM solutions that is ready for you. I give you an example of this. Our factory planning systems, our factory planning services. We are the partner of choice when deciding to engage into a project that this example here you see on the screen is a customer in Italy that decided to go in-house production of 100% rPET preforms, starting from an empty building and an idea, and we were able to accompany this customer from all the way from the solutioning, the design of the plant, all the infrastructures, and then end-to-end delivery of all the equipment required, support during startup, and then we continue to be linked with this Advantage Plus Elite services to support the customer with a continuous quality during startup. As I said, this continuous support, our Advantage Plus Elite, we call you solution, a service that will ensure that we deliver on a commitment and we maintain that. And last but not least, I would like to give you a quick overview of our recycled melt to preform system, the world's most sustainable system, injection molding system for production. As you can see here, this system is linked directly with the decontamination unit, like an EREMA, an NGR, and also other producers in the market that can deliver food-approved melt. So we link directly to this system the melt. So we do not have all the intermediate steps from the pelletizing, the storage, bagging of pellets, and then transporting the material, drying, extruding. So we do a direct link between the melt decontamination, so the equipment that produces IIV decontaminated food-approved melt, connected directly with our system. So what we have here is a significant energy saving by not re-drying and re-extruding the material. The energy savings and also significant carbon footprint savings. So very important to point out is that this system is not a complete new machine, is based on our HPP5E proven platform. It's a module of that system. So the machine is a complete HPP5E. We sold more than 700 of those systems all over the world. And we have the same tooling compatibility. We have the same options and also the same performance. So we give the same performance commitments as we give in a standard HPP5E system. The difference is that instead of having an injection screw here, we have a melt transfer pipe. And then what we call the universal melt interface that is also based on our proven technology of the dual shooting pot we had delivered for the RF back in 2010. So basically everything in this system is completely proven and validated. We have already sold 3 of these systems. We have some other opportunities on the pipeline. The first system is working since October 2021, and now we are delivering 2 systems in the next coming months. So we will have in middle of 2024, we'll have 2 systems in the market connected with EREMAs and 1 connected with NGR. And then we have other opportunities in the systems. So we hope, hopefully, we're going to be coming soon to the market with more updates on this. And this was it. I finished with this slide about our HPP 5E proven technology. And thank you very much for your time. And we are open for questions. Thank you.
Many thanks, Philip and Pedro, for the wonderful insights that you have shared with us. It's indeed, something which our region in the Middle East and Africa, particularly in GCC, many brand owners and converters are really looking at this area, moving towards circularity and the best possible product, or let's say the polymer that can really, be collected, sorted, and recycled. Obviously, is PET, the lowest hanging fruit, which can be easily collected, sorted, and recycled. And as we speak, or rather, as we are now, we can see quite a few converters and waste and recycling companies who are looking at this area and investing in these technologies, which you elaborated so much in detail. But before I go into all those details, I mean, there's some very interesting questions. Some interesting questions have come up, Philip and Pedro. So let's start looking into those much more interesting questions, before we wrap up this webinar with more, valuable takeaway. Question number one: can PET replace glass bottles for hot-filled products? If yes, can the design of the PET bottle have panelless to avoid label crinkling for better branding? Philip, perhaps you can take this question.
Yes, thank you, Ben. There are two parts to this question. Number one, with regard to hot filling using PET, if the temperature is below 92 degrees, which we see in most beverages, it is possible to fill with PET. And above 92 degrees, there are some proprietary technologies, there are some proprietary bottle designs which allow you to fill with PET above 92 degrees. But let's say for this case here, let's just focus on the beverages which are filled below 92 degrees, which is for the most part, most of the beverages we see in the market. Most of them which are hot filled, let's say above 85 degrees, it's going to include some panels. And the purpose of those panels are twofold. Number one is when you're filling the bottle with the hot liquid, that hot temperature liquid will try to deform the bottle. It will make the bottle soft and will try to deform it. And therefore, you need the panels to support it. And after you cap the bottle and the liquid starts to cool down, you create a vacuum effect, and the panels help resist that vacuum effect in the bottle. So the panels are important, but there are ways you can avoid using those panels. And we've seen a lot of innovation in the last 10 to 15 years, or I'd say last 10 years, where we have, for example, one simple solution is simply add more PET to the bottle to resist that deformation during filling, and also that vacuum effect after it is capped and cooled. But number two is we're seeing a lot of innovation by the blowing and filling OEMs, where they are introducing technologies in the base design, and also where they are actually deforming the base deliberately to compensate for that vacuum effect after the bottle is capped and starts cooling down. And in those cases, we are seeing that panelless bottles are being used for quite high temperature filling as well. So that hopefully that answers that question.
Right. Thanks, Philip. This is a very interesting question. Consumers believe glass is more sustainable than plastic, and even I felt once, before knowing this much about PET. How to convince them? Pedro, probably you're the right person who can give us some insights.
It's a very interesting question. I think that most of us, and probably the people that are asking that question, were educated in a time where we started to see selected collection of glass, right? And we were told, very rightfully so, that bottle was not waste, right? If you remember well, this came after a time where it was reuse of the bottles, and then we needed to start to have some kind of single use. So there was this concept of glass is not waste, you separate it and you put it in a separated bin, so it's not waste. So
Right.
what I did that a training to the kids of my school, my son's school, where I came exactly with that point. I said, okay, so why is this waste? And I was handling a bottle of PET. Why is the bottle of PET different than a bottle of glass in terms of considering it waste or not? I think that is the main source of the problem, because people see that they do separate glass in a certain way. After, if we go a little bit more technical, and I think this answered already the question, people need to realize that they cannot throw away a bottle of plastic. We need to understand that there's a value for it. Market is valuing it even higher than the virgin plastic, so there is an effective market for it. And secondly, if we become more technical, we just need to say that PET is liquid at around 300 degrees, and glass it's over 1,500. So we can easily understand that to go from bottle to bottle for PET, it's much more energy efficient. The carbon footprint is much lower than from a glass bottle in an ideal world, right? So the glass bottle would have to be grinded and remelted, and the remelt it's a highly intensive energy. On top of that, the transport of glass normally weighs 10 times more than a PET bottle. So 10 times, I'm probably exaggerating, but in this range. So it's always factors that make that plastic it's the most sustainable option if people do realize that the recycling of it is required and it is not waste.
Thank you, Pedro. Dwelling on the same point, I have another question from another standpoint, from the business standpoint, or let's say a shelf impact or look standpoint. Philip, probably you can take this question. In the GCC, glass is associated with premiumness. Can PET match this? If it can match, how can it?
So interesting question, and it's a good question coming from the GCC, because I do see many examples of this particular happening in our market. There are several ways that we have brand owners who are looking to launch a very premium PET package to replace their glass packaging, or just to introduce a very premium package in addition to their other PET packaging. So what they're doing, number one, for example, they're creating a heavier bottle, still much lighter than PET, but it's still heavier and feels much more firmer in your hand. We're seeing some brand owners who are playing with different base designs. For example, they can create a champagne base or other types of base designs which duplicate or have the same look as the bottle design. We're even seeing that a number of brand owners are including different types of closures. They can have flip-top closures, or they're even including crown closures similar to a glass bottles. In some cases, a labelless bottle. So in many of these cases, you have glass brand owners who are trying to duplicate glass bottles with PET bottles, and if making it so close, it's very difficult to tell the difference between the glass and PET bottles in terms of the firmness in your hands, in terms of the shape. But even going beyond that, PET, because of the nature of the material, allows you to create many unique bottle shapes that's difficult to do in plastic. And we have many different features like tethered closures, which can be very interesting for the consumers, and it also enables a very positive sustainability message as well. So there's many things you can do with PET that you cannot do with glass. So you have the premium, the ability to make a very premium package, and the ability to make a very sustainable package at the same time, like Pedro was talking about.
Brilliant. Thanks, Philip. And this question is again very interesting. Can PET or rPET or rPET be recycled over and over again? What is its degrading rate or the quality in terms of lifetime of a PET or rPET? Pedro, you want to take that?
It's a very interesting question. I see that people attending this webinar are really at a very high expected level. I think that's a question to which I don't know if we already have an answer, complete answer to the question. We do know that PET is infinitely recycled. We also know that there is a rate of degradation in that recyclability, that if we look at the big picture of things, in markets where the rates are still low, we don't see any effect of that circularity of PET. We see in some specific areas that do have a complete circularity for a long time already, that there is in some ways a need to bring some material to the flow to refresh a bit the flow, not necessarily to the PET itself, but to the effect of some additives have into that circularity. This is something that we observe, for example, in Germany, where there is this deposit return system that is mainly made in supermarkets, where basically you are recycling the same bottles to a certain percentage. In all other markets, it's very difficult to see this because there's first a very high rate of still virgin material, and the bottles that are recycled are always a bit different. So that's why I say it's a very interesting question without how should I say, a large scale answer today. The points that we know is that it's required to have some level of new material in the big picture of things. But today, and if we take the region there, this is a problem that probably we'll face in some 10 over years from now.
Right, thank you. This is another very interesting question which has come up here. The cost of rPET versus PET. This is a bothering point for brands and converters to go sustainable and at the same time be commercially viable. Where do you see this going with your experience in other developed markets such as Europe and North America? Perhaps this is a question, from my side.
Can give a point, and myself also. Maybe you start, Phil.
Yeah, I think both of us can answer this question because we both serve different markets. We both see things in different markets. So it is, in fact, one of the main things that we're seeing at Husky right now. And it's one of the points that we raised earlier, and the point that Pedro always mentions when he talks about rPET is that the demand for rPET today is very high. It's very clear that there's very significant commitment being made by brand owners and by national governments about how much rPET is supposed to be inside your packaging. And today, the supply has yet to catch up. So this is having two effects. Number one, costs are going up. And this is the point from the questioner about, okay, this is the main sticking point that they have, which we do recognize that there is a challenge today. And as a consequence, they can, if they want to use rPET, they will probably have to consider using lower quality rPET in the market. So we've seen a lot of variation in terms of the quality of rPET in the market, or the fact that brand owners will need to consider using lower quality recycled PET because that's the only thing that they can afford. And a lot of what we are working on Husky is all the technologies that Pedro was talking about is about how to mitigate that risk, how to mitigate that variability in rPET. Because if you have a lot of variability coming in as your input, you want to make sure that the variability does not increase in the injection molding process. You want to try to keep it as minimum as possible, and this is a lot of what our technologies are doing. Now, with regard to pricing, we're seeing a lot of variability, and it's really variable from country to country, depending on how many recyclers are operating there, how many commitments are being made by the bottlers. It's very localized. So I'm seeing maybe 1.2 times, 20% above virgin price, maybe 50%. In the worst case, I'm seeing double the price of virgin PET for recycled PET. That's the kind of the range we're seeing right now in the market. And this is stretching from Australia, for example, all the way up into, I would say, into the Middle East. Maybe Pedro, you're a global leader in rPET, so you probably have a better perspective than I do.
Yeah, no, I don't have much more to say, Phil. I think you said it. You said everything. The only thing I would like to add is legislation. So I think legislation is extremely important. It's playing a role. We saw that the prices in Europe for rPET versus virgin. This analysis I do with the prices, the rate between, or the difference between rPET and virgin. We saw that in Europe, even if the price dropped recently due to mainly to some accident of imports from Asia, but the prices dropped. We still see the gap. Means that price of virgin drop, price of rPET drop, but there's still a significant premium that kept the same. due to the demand, as Phil was mentioning, where in areas where the legislation is non-existent or we are much more relying on brand commitments and on marketing, that gap narrows every time that the rPET pricing becomes too high, right? So then people fade a little bit in the commitments. So this is one thing I would like to add. So the legislation pushes those boundaries. And the second point I think is very important, and mainly in the region where I think the discussion of the industry needs to be, is that the rPET needs to be local. So we need to focus very much into collection, into creating the necessary capabilities locally to provide for the rPET. Because every region, as Phil said, every region has demand. Every country is putting legislation or putting objectives in terms of recyclability. So we need to ensure that the circularity itself is as global, as local as possible.
I can't agree with you more on this point, because over here that's exactly what is happening as we speak. We have the Circular Packaging Association, which has been established, which is working around this very point, that recycling, sorting, recycling, all of that should be localized. It's only then that it has value, and as the volumes increase, the prices would obviously come down. To complement that is the legislation, which you also highlighted. I think together this should happen. If not very far, we are very near to that, and I'm sure that the rates will be balanced and we'll be able to take rPET for many more brands and many more SKUs, right? There's one technical question I would like to ask before we end this. We have many other questions, but we'll address it later through our report, which we're doing in the magazine. But this last question, what about IV rate, or IV drop rather? What about AA and the transparency of rPET is what? Pedro, you want to take that?
If you recall the slides I just presented, it depends on the rPET, the transparency question. When we talk about IV drop and AA, normally the IV drop, the IV of an rPET is targeted for the application. So normally we see that the rPETs are tendentially around 0.8, 0.82 IV. And the IV drop on the injection molding machine is exactly the same as you would have with virgin. So there's no more IV drop. The IV drop in the injection molding machine is linked to the humidity that we get after the dryer, and the hydraulic degradation that may happen, or that happens in the injection molding screw in the liquid phase. And it can also be linked to mechanical degradation, but this is I don't think that there is going to be a difference on that between the rPET and the virgin typically. So the IV drop for me is a non-question concerning rPET or virgin, so it will not have an effect. The AA, it also depends on the initial AA, because the AA on rPET normally specified as below 1 ppm. I honestly believe that we need to do some optimization of the full chain to see, do we really need this 1 ppm, for example, because to achieve this 1 ppm under certain technologies of mechanical recycling, we need to invest more energy, and probably we don't need to reach 1. We are okay with 5 if we want to produce CST, for example. But the AA, there's opportunity for waste reduction in the overall stream, and we are currently in discussions with different players to get there. But again, the AA is the AA addition in an ASCII machine, optimized ASCII machine, is around 3 ppm. So you would be one, you would be 3, 4, below 4, 5 ppm. So it's not. It's also not linked necessarily to the rPET. It's linked to the initial AA and the final AA that is linked mainly to the residence time in the liquid phase of the PET, being it rPET or PET. You would have similar rates on AA. I hope that this was clear enough and not too technical.
Sure.
Yeah, just to add to that, if you, in many cases, you're going to have specification when you purchase your rPET, and they will include specification with regard to AA, and I've seen a lot of them, and they would say it's 1 ppm, and they would state the IV just like Pedro mentioned. So whatever specification you get for virgin about the size of the chip and the AA and the other types of properties, a good quality recycled PET is supposed to have similar types of specifications as well. The same types of parameters will be indicated there.
Yeah. The variability is more on things like crystallinity on solid contaminants, on IV variation, because you can have some IV variation that can have an effect then on how the system modulates to that IV variation. Not necessarily on drop, but on if you have a distribution of IV, you need to make a system that is able to handle that distribution of IV in the best way, the most capable system to handle that distribution. So the variability is more on that type of areas that are linked to a mechanical recycling process and very much linked to the incoming quality of the material.
Brilliant, brilliant. Thank you very much, gentlemen, for your insights.
Thank you.
I think it was a learning curve, first of all, for me as a journalist. I'm going to write this article in a better way now, because I'm going to put a report together on this webinar in the next edition of Packaging Middle East and Africa magazine. And perhaps we can, it really throws a lot of light and answers many of my questions, especially on rPET from a technology standpoint. And we have touched a few questions on the business standpoint as well. I think overall, we are getting there. The Middle East and Africa, particularly GCC, and within GCC, these two countries, UAE and Saudi Arabia, have taken the lead to move towards circularity in rigid plastic, especially in this rPET that we are talking about. So I wish you all the best. I think you have you're going to be busy, promoting this technology, or rather educating, all of us, especially brand owners and converters, to move from PET to rPET to be more circular. And wishing you all the very best. And we can come up with a special report in a magazine. And till we meet next. And one more very quick point for all our delegates. Thank you for joining us, and thank you for all your wonderful questions. And we are going to be in touch with you very soon. Thank you.
Thank you very much.
Thank you very much.
Thank you, Pedro, and thank you, Philip, once again.
Thank you. Bye.
Thanks. Bye.